is doubling time. Doubling time simply means the time it takes the initial value of y to be twice. That's doubling time. We want to find the time that it takes y to be twice of the initial value. So we use the same equation that we had before. Y is equal to y sub 0 e to power kt. And now since we want to find the doubling time, it means that we substitute 2 y sub 0 for y. And this becomes 2 y sub 0 e k t. So the next thing that we need to do is to divide each side by y sub 0. This implies that 2 is e k t. Take ln of each side. We have ln of 2 is ln e kt. And as we have said before, logs drops exponents. This will be dropped up front. And we have ln2 is kt lne. And no, this is 1. End up with ln2 is kt. Now divide by k, we have t is equal to ln2 over k. So if we know the constant, we'll be able to get the time to take for a value to double. All we have to do is divide ln2 by the constant. Or if you want to find the constant, we divide ln2, back to this formula, we divide by ln2 by the doubling time. Okay, that's part 1. Part 2, just like doubling time, this is the time it takes an atom to decay to half its value. We use the same thing, same formula. This is equal to y sub 0 e kt. That means this time takes y sub 0 to be half its value. This means that we substitute 1/2 y sub 0 for y, right there. So this becomes 1/2 y sub 0 is y sub 0 e k t. Just like what we did in the previous one, we divide each side by y sub 0, and we have 1/2 is e k t. Take ln of each side. So this one will be ln. This side will be ln. And this translates to negative ln2. And this is just kt. And now, dividing by k, we get the time it takes an atom to be half its value, and this is negative ln2 over k. This is half-life. Find that for half-life, this is negative. If the negative sign is not there, if we can write this way too, ln2 over k, in which case k, previous one doubling time, since this is doubling time, if you don't have it this way here, k must be positive. Now, next thing is to do an example to show you how you apply this. And this is about population of a town in the year 2010 was 90,000 people. The question is, in what year would the population be 180,000 if the rate of growth is 2.4% per year? So back to the doubling time, we say that t, doubling time, t is ln2 over K. In this case, K is the growth rate, which happens to be 2.4%. This is 0.024. That's K. So T is equal to ln2 over 0.024. And this is equal to 28.8, like that. Now we can round this to the nearest whole number. So this means that doubling time is 29 years. So the question is, in what year will the population be 180,000? Initial population was 90,000 in the year 2010. Then it will be, the population will be 180,000 in the year 2010 plus 29. So we got here. So to be 180,000 in the year 2039.